The ion-electron method refers to a method for writing the net ionic equation for a redox reaction that's happening in aqueous solution. Okay, and the way you would do this is you first identify the species, that means the ions or the molecules that are actually involved in the half reactions. Okay, so you need to identify your half reactions. Then you balance your half reactions. And then you combine your half reactions so that electrons lost equals electrons gained. So let's take a look at this unbalanced redox reaction. We looked at this last time, so we're going to try to balance it this time using the ion-electron method. Okay, what would be your unbalanced half reaction for this? What did we say the oxidation numbers were? Your copper went from +2 to, from 0 to +2, right? And your nitrogen went from +5 to +2, right? So what's our half reactions? Your copper became copper ions with a +2 charge. That's the only thing we write. Okay, we don't write the whole copper nitrate thing, because what do we know about copper nitrate in solution? When we're writing ionic equations, we'll have to separate this copper +2 nitrate. So the only thing that's really involved there as far as that half reaction is concerned is the copper ion. So that's your half reaction. And what do you call this half reaction? Oxidation or reduction? Going from 0 to +2, this is an oxidation, right? Increased oxidation number. What about your, in fact, we already seen that this was what? 2 electrons lost, right? So you know that you're going to have 2 electrons over here. And what's the other half reaction? HNO3 to NO. But what do we know about HNO3? It's one of the 6 strong acids, so in aqueous solution it's completely dissociated, so we don't write it as HNO3 when we write net ionic equations. What do we write it as? H plus nitrate, right? So it's H plus nitrate, but H plus is not involved in the redox. It's just the nitrogen that's reduced. So the only species that we write when we write our half reaction is NO3 minus, at least at the outset. Okay, we'll find later that we're going to have to add back that H plus, but we just write the species as a first step. We just write the species that are actually involved in the reduction and the oxidation. What happened to the nitrate? The nitrogens in the nitrate got reduced. The ones that got reduced ended up being part of the NO molecule. So that is your other half reaction. This is your reduction. Okay? So those are your 2 half reactions. So what you do is you balance those 2 half reactions, and then you combine them so that electrons lost equals electrons gained, and you got your overall equation. So how do you balance the half reaction?